The Type-093B nuclear-powered attack submarine represents the most current and advanced iteration of China's Type-093 class, signifying a comprehensive and multifaceted technological evolution that impacts its design, armament, stealth, sensor capabilities, and strategic operational doctrine. This vessel is not merely an incremental update but a substantial departure from the foundational Type-093 and the intermediate Type-093A models, which were primarily focused on achieving basic regional anti-ship and anti-submarine warfare competencies. The development of the Type-093B indicates a matured design and industrial capability, shifting the focus towards creating a platform with global range power projection, independent strategic strike capacity, and a survivability profile that challenges modern anti-submarine warfare networks. The most immediately observable and structurally significant modification, confirmed through detailed analysis of high-resolution imagery, is the deliberate and calculated extension of the submarine's pressure hull. This extension is not a uniform lengthening of the entire vessel but a specific insertion of a new hull section directly aft of the sail structure and forward of the reactor compartment. The dimensions and placement of this extension are analytically consistent with the incorporation of a dedicated vertical launch system module. A VLS module is an integrated unit comprising multiple individual, sealed missile launch tubes that are permanently built into the submarine's pressure hull. This architectural approach is fundamentally different from and superior to the method of launching missiles through the standard 533mm torpedo tubes. Launching missiles via torpedo tubes is a sequential process that is limited by the reload rate of the tubes, constrains the physical dimensions and thus the range and payload of the missiles, and temporarily dedicates those tubes to missile launch, thereby preventing their use for torpedoes and creating a potential vulnerability window. The dedicated VLS bypasses these limitations entirely, allowing the submarine to carry a larger, specialized arsenal of long-range missiles, maintain a state of constant readiness for strike missions without compromising its anti-submarine warfare posture, and execute rapid, salvo launches of multiple missiles against a variety of targets. The strategic and operational implications of this vertical launch system capability are transformative for the People's Liberation Army Navy. It elevates the Type-093B from a tactical naval asset to a platform of strategic significance. The VLS cells are assessed to be capable of housing a mixed loadout of advanced cruise missiles. This includes the YJ-18 anti-ship cruise missile, a weapon system known for its sophisticated flight profile involving a subsonic cruising phase for long-distance range, followed by a terminal supersonic sprint at very low altitude, a combination that severely compresses the reaction time and degrades the interception probability of enemy fleet air defenses. More significantly, the VLS enables the deployment of long-range land attack cruise missiles. These weapons, analogous to the American Tomahawk, are precision-guided conventional munitions capable of striking high-value fixed targets such as command and control centers, logistical hubs, airfields, and critical infrastructure from standoff distances of over 1,000 kilometers. This land attack capability grants the Chinese military command a covert, survivable, and persistent strategic strike option from the maritime domain, complicating an adversary's defensive planning and forcing the allocation of significant intelligence, surveillance, and reconnaissance assets to monitor vast oceanic areas. It effectively allows a single submarine to influence events on land far beyond the horizon, a core tenet of modern power projection. The second paramount technological advancement, identifiable through analysis of the stern hull form and the absence of a large, open propeller, is the integration of a pump jet propulsor. This represents a generational leap in submarine propulsion technology. A pump jet propulsor operates on a different principle than a traditional propeller. It consists of a multi-bladed rotor, similar to a ducted fan, encased within a stationary annular shroud. The primary acoustic advantage of this system is its superior management of water pressure and flow, which dramatically suppresses the phenomenon of cavitation. Cavitation is the formation of water vapor bubbles on the low-pressure sides of rapidly spinning propeller blades, which then collapse violently, generating a distinct, high-frequency broadband noise that is a primary signature detected by passive sonar arrays. A pump jet mitigates this effect across a much wider band of operating speeds and depths, making the submarine's acoustic signature significantly quieter and more difficult to distinguish from ambient ocean background noise. This reduction in radiated noise is a direct and massive enhancement to the submarine's survivability and lethality. It allows the Type-093B to approach more closely to defended areas, evade detection by hunter-killer submarines and maritime patrol aircraft, and maintain the tactical initiative during engagements. The propulsor is also likely coupled with more advanced electric motor drive systems, potentially utilizing permanent magnet motor technology, which offers higher power density, greater efficiency, and lower mechanical noise compared to traditional direct drive turbine systems. Complementing the advanced propulsor are extensive hydrodynamic refinements to the hull form. The sail, or fairwater, has been completely redesigned with a pronounced airfoil profile, featuring smoothly tapered leading and trailing edges that minimize hydrodynamic drag. The junction where the sail meets the main hull is now seamlessly blended with complex curved fairings, eliminating the sharp right angles that were present in earlier variants. These angles are significant sources of turbulent flow noise, which can be detected by sensitive non-acoustic sensors. The entire outer hull surface is also likely coated with a layer of anechoic tiles. These tiles, made of specialized rubber or synthetic polymers, serve a dual purpose. They are engineered to absorb and scatter the acoustic energy of incoming active sonar pings, reducing the strength and clarity of the return echo, and they also dampen internal structure-borne noises emanating from within the submarine, preventing them from radiating into the surrounding water. Internally, the submarine's architecture certainly employs a sophisticated suite of sound silencing techniques. The most critical of these is the rafting of major mechanical components. This involves mounting entire assemblies, such as the steam turbine, reduction gears, and turbo generators, onto large, heavy, and resilient platforms or rafts. These rafts are then isolated from the main pressure hull structure by multiple layers of flexible dampers and springs. This system acts as a mechanical filter, preventing the high-frequency vibrations generated by the machinery from being transmitted directly into the hull, where they would act as a loudspeaker into the ocean. Secondary systems, including all pumps, compressors, and fluid handling systems, would be mounted on their own individual vibration isolators, and connecting pipes would use flexible sections to further break up sound. Transmission paths. Beyond stealth and armament, the sensor suite of the Type-093B has undoubtedly undergone a concurrent generational upgrade. The bow is expected to house a large, modern spherical active-passive sonar array, providing all-around coverage with high sensitivity. The submarine likely also features flank array sonars installed along the sides of the hull, providing very long-range passive detection capabilities, and a towed sonar array housed in a dedicated tube on the top of the stern. A towed array is a long cable with hydrophones that is streamed behind the submarine, allowing it to detect very low-frequency sounds at great distances while being isolated from the submarine's own self-noise. This combination of bow, flank, and towed arrays creates an integrated acoustic sensor system of formidable range and discrimination. The submarine's combat system, the central computer that fuses data from all sensors and weapons, would be a new generation capable of handling the immense data load, performing multi-target tracking, and providing fire control solutions for its diverse weaponry in a highly automated manner. In terms of its current status and force integration, the observed pattern of construction at major submarine yards indicates a sustained, serialized production run. The sequential launch of multiple hulls, their progression through outfitting, dockside testing, builders' trials, and finally acceptance into the fleet, confirms that the Type-093B design has passed the prototype stage and is a standardized, operational asset being produced in meaningful numbers. This serial production is a clear indicator of the plan's confidence in the design and its intent to establish a significant force of these advanced submarines. The exact number in service is a closely guarded secret and a dynamic figure, but the consistent reporting and imagery analysis point to a fleet that is growing year by year, forming a new, high-capability core of the plan's attack submarine force. The operational roles assigned to the Type-093B are consequently diverse and strategically significant. It can function as a long-range, open-ocean hunter-killer, tasked with tracking and, if necessary, engaging adversary ballistic missile submarines and high-value surface groups, including carrier strike groups. Its stealth allows it to operate as an advanced intelligence gatherer and barrier patrol in contested zones, posing a constant and credible threat that ties down enemy defensive resources. With its land attack cruise missiles, it serves as a strategic strike platform, holding an adversary's homeland at risk and adding a new, unpredictable dimension to campaign planning. Furthermore, it is a key component in the protective screen for China's own emerging carrier battle groups, providing the primary underwater defense against enemy submarines and contributing to the overall integrated air and missile defense network. The Type-093B must be understood as the critical technological and operational bridge between China's historically less sophisticated nuclear submarine fleet and its future generations. The practical, hands-on experience gained from designing, fabricating, assembling, testing, and deploying this class has provided Chinese naval architects, engineers, and the defense industry with invaluable, irreplaceable knowledge. The mastery of pump jet propulsor integration, the structural challenges of incorporating a VLS module, the refinement of advanced acoustic silencing techniques, and the software and systems integration for a new combat management system are all foundational competencies that are directly feeding into the development of the next-generation Type-095 class. The Type-095 is anticipated to be built on a new, possibly larger hull form designed from the keel up with these technologies as a baseline, promising even greater levels of automation, stealth, and overall operational capability, and the Type-093B program is the essential prerequisite for that future capability.